Okay, I'm Calvin Freed, and this is lab number 2 for GT Physics 2211 on motion of a falling object. Introduction. The purpose behind this lab is to measure an object's motion and velocity for being dropped at a position of rest. And doing this, we're testing the effects of gravity, and then we also test the gravity combined with drag to determine how they affect the motion of a falling object and to compare the differences between the two. The experiment I did it was conducted in tracking the motion of a falling object, and then I compared it to 2 computational models, one with drag and one without, to compare the effects of gravity and drag on the object and test how accurate a model would be to predict this observed motion. The results preview. Drag forces addition makes a difference in the acceleration, velocity, and position, so pretty much everything we're measuring of the falling object, and when compared to the models that don't take it into account. For some of the principles of models, it's just the force of gravity and the force of drag we're using, and the net force. Gravitational force of drag. This image is actually of the video that I used. And in this, it shows like the vector of gravity pulling the object towards Earth's center when it's not being held by hand, and then drag force upwards against the motion, going against it, so going up in the air. These are some of the equations we used. This is an equation I use, and then these are the variables in the equation. For the system surroundings and initial conditions, the gravitational force is a constant, so it's constant like gravitational force acting on the object. It applies a force proportional to the mass multiplied by the acceleration constant, about 9.81 meters per second. The initial velocity is 0 because the object is dropped from a position of rest. The drag force is the air resistance against the direction of the motion of the falling object. It's calculated later in the models. The falling object, the basketball itself. The initial height that it's dropped from is about 1.824 meters, and the air resistance against the falling object creates the drag. Experiment. I discovered was that the object is low downwards until it hit the ground and reach rest. Be self-explanatory. But here's the actual video that I used on the tracker. Here's the graphs that complement the chart. And then for computational models, this is one of the gravitational force on its own. Pretty much all I adjusted were the initial conditions, which is the mass, the position, I also had to mess with the vectors, and then how long the time looped. This is what it looks like when it's ran. This is the graph of motion carrier, this is the position, and this is the velocity over time. Finish up soon. Okay. This is one where I take into account drag. Pretty much the only big difference was that I edited the speed value and edited the net force to put it in there. And this is what it looks like when it's ran. Pretty similar graphs, pretty similar landing points, except when you compare that, you can see the differences. So for some possible sources of air, sorry about that. It's a perfect perpendicular. We're displaying the gravitational and drag force combined on the falling object. The object and no drag force would just continue accelerating forever at like a constant rate, as you can see from the graph. And if the object was thrown downwards with the initial velocity, would the terminal velocity differ from the case of the object falling from rest? No, the terminal velocity would not be affected by an initial velocity applied. It would still have the same terminal velocity. It would just possibly reach that point faster. The conclusion: the computational models are more digestible and ideal, but it's just more important. It's important to go through the experimental motions, and to get practice in the physics concepts in the real world, and practice comparing these values to ideal values. And then using drag and gravitational force combined model alter the values of position, acceleration, velocity, and introduce like a clearer perspective on terminal velocity on the falling object. And